Okay, so I'm Don Wunsch. I'm the Mary Kay Finley, Missouri Distinguished Professor of Computer Engineering at Missouri University of Science and Technology in Rolla, Missouri. And we are here in the Cologne-Bonn Airport. So we're in a coffee shop in the Flughafen of Berlin-Cologne. And we are here to interview Juergen Zimmerman. We'll say a little bit about that in a moment. And English speakers, just be patient. I'm going to say a little bit in German. Es freut mich sehr, der Professor Juergen Zimmerman kennenzulernen hier. Es ist schon ein spannend, sehr interessante Rede, das wir gemacht haben, und ich bin sehr froh, mehr mit Ihnen zu sprechen in diesem Interview. Also für unsere deutsche Anhörer, alle können sehr stolz von seiner Muttersprache Forschungsbahn. Okay, so Professor Zimmerman, would you tell them we'll get into the questions, but in a moment. But if you would maybe just start with your name, contact information, your current affiliation with both Aachen Informs MIT, and also just where you got your PhD. And then we'll get into more details about the story during this story.
Okay. My name is Hans-Juergen Zimmerman. I'm living in Aachen, or Aix-la-Chapelle, as it is called in French. Corneliusstraße 5 in 52076 Aachen. I am my email address is zi@or rwth-aachen-li. I am emeritus but still active at the Aachen Institute of Technology, and also active in companies which I have founded. That is the INFORM, Institute for Operation Research and Management, MIT, which stands for Management of Intelligent Technology, and the Foundation ELITE, which stands for Laboratory for Intelligent Techniques Engineering.
And we'll take a moment and just show them each of these cards. In English, the back in German, from Management Institute Technology, and this one. Okay, and so we started with the fascinating story that you told me that began in your childhood of how you came to get into the area of science and technology. So I'd love to hear it again. It's absolutely fascinating.
Okay.
So instead of such a structured question, let's just go kind of free form with the story of how you came to study in there. So.
Okay, I was born in 1934 in Berlin and moved 4 years later to Silesia, which is a state in eastern Germany. And there I stayed until 45, when the Russians were approaching the last World War, and we had to flee a couple of times. with my four sisters and brothers, which I had, and we ended up in Saxony, in Waldheim. There I went to school, to high school, and I always wanted to become an engineer. I was always working in electrical trains and all that type of things. And there were three things which I definitely did not want to become, which was a civil servant, a businessman or bookkeeper, and a teacher. Then after 4 years high school in Saxony, I was told by the secretary of the director of the school that presumably I would be fetched 2 or 3 days from that day in order to be sent to the uranium mines for re-education, because she was 150% communist and I was in the Protestant view, so we didn't get on well with each other. So I only had the choice to take my rucksack and go away and try to get to Western Germany. That turned out not to be possible legally, so I had to cross the border in a foresty area in the Harz Mountains, where I succeeded. I was shot at but not hit, and I ended up a day after or 2 days after that first flight in Frankfurt in Hesse, in Western Germany. There I found a job. After 2 days, I was 15 or 16 at that time, and within a year or a year and a half, we got the rest of the family, which is two sisters, 2 brothers, the mother and the father, from Eastern Germany to Western Germany, so that we were all living in an old school building in Frankfurt. I had a job packing in a mailing company, and the boss, the director, wanted to convince me to make an apprenticeship in business. A business, of course, was one of the 3 things I never wanted to become. Since my parents, however, kept talking to me and trying to convince me that I couldn't stay without any formal education for the rest of my life, I accepted the apprenticeship and made a business apprenticeship for 2.5 years in Frankfurt. Still wanting, of course, to become an engineer. To become an engineer, however, I would have to study, and in order to be able to study, I would have to make a school leaving examination which allows me to study. Full stop.
No.
Okay. So I got a job as a head of an apartment in a company for 2.5 years, and during that time we still had working our 48 hours at that time in Germany. I went to night school and prepared my school leaving examination, which I was still missing, and I passed it after about 13 months. And then, of course, we had again the questions.
So you were working 48 hours, and then you were in addition 4 hours a night.
It was 8 hours work, then half an hour away, then 4 hours class, night class, and then probably 2 hours homework, more or less.
And that's 6 days a week.
Yeah. So wow. It was not much time left to sleep.
Wow.
But
a
still,
lot of work, yeah. A young man can do that, yeah.
If you really want to do it, you can do it.
Yeah.
And then after I had passed that examination, I asked again, what should I do? And my friends told me, don't study, isn't worthwhile, and you have a big career in front of you in that company where I had my department. And I decided, okay, I always wanted to become an engineer. And about 30 kilometers from Frankfurt, there was an Institute of Technology which has just started a new program called Wirtschaftsingenieurwesen, which is similar to management education for engineers. It's a combination of a management study with an engineering study, which could be either mechanical engineering or electrical engineering.
And that was already in Aachen.
No, that was in Frankfurt.
Oh, in
and
Frankfurt.
Darmstadt is
Darmstadt,
is 30 kilometers south of Frankfurt.
Right, and it now it's called Technische Universität Darmstadt,
Yeah.
but back then it was called something different.
Technische Hochschule.
Okay, that's the same place.
Yes.
Okay.
The Institutes of Technology in German is Technische Hochschule.
Yeah.
And after 70, most of the Technische Hochschulen felt compelled to change their name into Technical University.
Yeah.
So Darmstadt is now also Technical University. Aachen, by the way, not. We have kept the LWTH, which is Rheinisch-Westfälische Technische Hochschule.
So,
Because that was in discussion when I came to Aachen, but people at the Aachen University, the Institute of Technology, are pretty proud. They said, why should we change our name to university? We are well known and good enough as a Technische Hochschule. So we kept it.
both of them are outstanding institutions.
Okay, so I studied my engineering, and that started in 55. Got my bachelor in the double study. Then I had to work again because I had to earn my living. I couldn't expect any money from my parents. Then I went, after further half year of work, earning money, to Berlin, to the Technical University in Berlin, where I got the second half of the study. Again, Wirtschaftsingenieurwesen, which corresponds to a master in industrial engineering, closest. And then went into industry again to Siemens, from where I was called again to the university the year after that. And then I was offered a scholarship in Great Britain. And I insisted that if I went to Great Britain, I would only go to either Oxford or Cambridge. And they arranged a college in Oxford, which accepted me. So I studied 1 year postgraduate study in Oxford, returning from Oxford to Berlin. I got my PhD, and my dissertation was published right away as a book. And in the preface of that book, I thank people in Oxford for their help, I guess. Now,
and before we go on, the title of that dissertation translates to Operations, Research and Production Policy.
Production Management.
Production Management, but it has a German title. It was written in German.
Das ist wissenschaftliche Entscheidungstheorie und Produktionspolitik.
And that was your first scientific technical
That
publication.
was my first publication as a book, and that was all published right away, and obviously also sold in the United States.
In welchem Jahr?
That was in 56. Okay, and then I went again into industry to the European subsidiary of IT&T, which is located in Stuttgart, in the south of Germany. and there I became finally the head of the production control department for one of the divisions, until I received a telephone call in which I was asked whether I wouldn't like to come as a visiting professor to Urbana in Illinois, to the University of Illinois, in the Department of Business Administration. After some considerations, I was given leave of absence from IT&T, Standard Electric Lawrence, promising that if I would return to Stuttgart, I could first travel in the United States for 10 weeks, and then I would get a very responsible job in Stuttgart. So I went to the United States. They insisted that I came with an immigration visa. It was a little bit difficult, but the president of the university helped me very much. And I taught at the University of Illinois. I had a joint appointment in industrial engineering and the business school, operations research. And they had asked me to come because in my dissertation I mentioned in the preface the thanks to the people in Oxford. So they assumed that I would know English well enough and they wouldn't have to ask. In fact, they did never see any certificate from me. Then I had some other appointments in Berkeley and Arbor and Santa Barbara in California, and I returned to Germany in 1967 to the University or the Technische Hochschule Aachen. I had an offer from there, and Aachen and Munich were the optimal places in Germany for operations research. They had the best computer equipment and so on.
And they're still both fantastic places.
And they are both members of the Excellence Initiative in Germany. When I came to Aachen, by the way, we had 8,700 students, and now we have 42,000.
Wow.
So, and there I had the chair, the new chair for operation research, which was located in the faculty of business and economics. You want me to go on?
Oh,
okay.
Please do, yeah.
Now, the situation was not too good for operation research because nobody in Germany, or hardly anybody, knew about it, and my colleagues at the university as well as my students didn't believe that it was something important. Now, of course, I couldn't prove it mathematically or otherwise, though I thought, okay, the only way that came to my mind to prove the importance of operational research was to found a company which was not connected at all to the university. It was called INFORM, which was the abbreviation for Institute for Operations Research and Management. And I decided that this company should only do operational research and prove that it could save other companies so much money that it could grow itself quite well. That was one of the institutions that in the meantime has more than 600 employees in Aachen and is located still at the southern Silicon Valley of Aachen.
Yeah, you have a nice picture of the footprint of the company.
Yeah, that is a part of the Inform campus, as it's called now. And Inform has has 6 divisions now, concentrating in different areas. One of them still is limited to the applications of computational intelligence techniques. So now, when I arrived in Germany, I found that Germany had two operation research societies, one for practitioners and one for theoreticians. And that was very surprising to me, and did not seem to be justified at all, because the United States, from where I came, only had one, and that was much larger than Germany. So I founded a new German OR society by joining these two, and this was then called German OR Society, Deutsche Gesellschaft für Operationsresearch, which was pretty successful. I was president for a couple of years. But then I observed that Europe was in a very suboptimal situation with respect to operational research, because if you wanted to know, for instance, in Germany, what was going on in Italy or France, the best way was to call colleagues in the United States. And that was certainly not optimal from the point of view of operations research. So in 1972, when there was the 3rd annual meeting of IFOS, the World Organization of Operational Research, in Dublin, in Ireland, I called the presidents of the national European societies together, and we discussed. And a few years later, 2 years later actually, after 2 more meetings, we founded EURO, the European OR Society, which is a big success. It is very active and has about the same number of participants as the American Society. And then I lectured normally also on empirical decision theory. And after one of these lectures at the end of the semester, I came across the paper by Bellman and Zadeh in Management Science in 1972, Decision Making in Ill-Structured Situations. I was very excited about it.
Ill-structured situations or environments?
I think environments. I was very excited because operational research so far was considered to be only applicable to very quantified low-level operation and not to leading decisions in companies or other institutions. However, this paper also contained a few points, assumptions, which I could not accept, and so I called Professor Zadeh in Juergen and went there after 3 weeks, and we had 2 or 3 weeks discussion on the topic of appropriateness and applicability of fuzzy set theory to human decision making. After I had returned to Aachen, we started a kind of 5-year series of research projects in parallel, exploring fuzzy set theory mathematically and also the properties of the so-called quantifiers. These are the operations and or in set theory, the union, the intersection, the negation, and so on. And in parallel, with a team of psychologists, mathematicians, engineers, we researched how the theory really corresponds to real human thinking and decision making. And the first publications of fuzzy set theory actually concern these results. There was only one place in the world that did the same type of research that was in Canada. And the reason I think was that this type of empirical research is extremely expensive. We checked at that time and compared our axiomatic research, mathematical research, with empirical research, and we found that empirical research costs about 10 times as much focus on one publication. So, mathematical application costs essentially only a tenth of the time to prepare. So after about 10 years, the German foundation, research foundation, didn't finance that anymore. So unluckily, this type of research was finished in the 80s. I think it would still be very useful if we would still do a number of things, because primarily in fuzzy set theory, it has become a mathematical theory, and there's hardly any application at the present, and there's hardly or absolutely no research into the interface between real human thinking and formal decision modeling. Then something very interesting happened. We only had two universities in Germany that did research and offered lectures in the fuzzy area. In Aachen we offered about 4 or 5 different courses in the fuzzy area, but there was not much response in the practice. We only had the 2 universities that offered anything in fuzzy set theory at all. And then the German journalist went to Japan and came back, returned to Germany very excited, and wrote that Germany would now lose another market to Japan, because in Japan everything that was modern and high-tech was called fuzzy. And they were offering on the market fuzzy washing machine, fuzzy video cameras, fuzzy subways, and so on. And in Germany, you could see nothing in the media. And this article led to an explosion in Germany of fuzzy publications in application-oriented journals. In fact, hardly any IT-related magazine dared not to publish anything on the application of fuzzy control at that time. And the number of universities that offered courses in fuzzy sets doubled or tripled within probably even a year.
Now, were these organizations that you founded, Inform, MIT GmbH, and Elite, were these already in existence at the time of this?
Now, Inform, of course, was already in existence because it had been founded for the application of operating research. Mm-hmm. MIT and Elite, the foundation, was founded in '91 because after that explosion of fuzzy literature, even the Ministry of North Rhine-Westphalia, that's the state in which Aachen is, offered multi-million sponsoring of fuzzy activities, fuzzy research activities. But in order to get it, we had to found a new company, and that was Management of Intelligent Technologies, MIT, and the foundation Elite. So we could start and go on, with application as well as with empirical research in the fuzzy area. What I observed, however, was that there were rather few people distributed over the world working in that area. And I was convinced that there should be much more international worldwide communication, which was not in existence at that time. So I invited a number of prominent people working in that area to the first part of a founding operation in Brussels in 94, which included more or less the European persons working in Fascisets. And 1 month later, we had the second installment of the foundation of IFSA on Hawaii, where the United States, Japan, India, China joined the new institution of society called IFSA, Internationally Fuzzy Systems Association. I was a couple of years again president, and it worked quite well, the same as the European Association, which was restricted to Europe, but IFSA was now worldwide. Applications went on quite well as research, but there were 3 areas which had actually the same or very similar motivations, namely neural networks, artificial neural networks, genetic algorithms, or enumerative programming, evolutionary programming, and fuzzy set theory. There had been no communication between these 3 areas, and 1994 they came together at 3 independent conferences, one in Yokohama in Japan, one in Aachen, Germany, and one in the United States, and they all used the term computational intelligence for these 3 areas, and they have kept this term, even though the origin of the term computational intelligence is probably already 2 years older, because 2 years before that it was used for a new journal in Canada, which was focusing actually on artificial intelligence and wanted to be somewhat special. So there's the term, but the content as the computational intelligence as we are using it now was actually coined in 1994.
Right. And you attended the first World Congress on Computational Intelligence in Orlando in '94 as well.
Yeah. Certainly. That was one. I chaired the conference in Aachen and attended one in Orlando and also in Yokohama. I attended actually all 3.
Good, very good. So we talked about your first paper that you published was the book that was published. Not only your dissertation, but also the book that came out of it. But also, I wanted to get the first paper related to paper or book, whatever your first publication was in the computational intelligence area.
Now, my first paper in artificial intelligence was actually in 1992. The first paper that I published was in 1964. That was still in German. And the first one in English was in 1966 in English, but that was on inventory systems.
Okay.
And the
what was the title of that one?
Periodic-wise work of perpetual inventory systems. Okay. And it was published in Production and Inventory Management.
Okay, and the first publication in German was the book?
Yeah, that was a dissertation, which finally led me to United States.
And what year was that?
That was in the publication, 1961.
And the dissertation?
No, that was a dissertation.
Okay,
And the invitation was in 1967.
Okay.
And I'm just looking the first proclamation
fuzzy system related, I guess.
was in, must be later on, yeah. It was in 1976. It was in German. Unscharfe Entscheidung in Multikriteria-Analyse. Fuzzy decisions in multi-criteria decision making. And then they came quite often. There was another in 76, 77, and the first English was in 1978, and that was in the new Journal for Fuzzy Sets and Systems, in the first issue, and the paper was Fuzzy Programming and Linear Programming with several objective functions.
Good. And you founded the Journal of Fuzzy Sets and Systems, is that correct?
I founded the Journal for Fuzzy Sets and Systems, as well as the European Journal for Operations Research. Both journals do still exist and are the largest worldwide, I think, in their respective areas.
What years were those founded?
64 and 60 and 76 and 74. So actually they were founded always 2 years, they were started 2 years after the respective society, the Euro and IFSA was founded.
And I'd like to back up a little bit. One is slightly back and the other one is way back. So first let's go way back. Were there any individuals who were particularly important in helping you get interested or active in science and technology during your formation?
No,
you mentioned one in a,
yes.
You mentioned one in a negative way. That person induced you to escape to West Germany. But any positive influences in engineering? Yes.
Now, engineering, I mentioned already. I always wanted as a child to become an engineer. Mm-hmm. So that came from inside. Mm-hmm. And science was actually an accident, because I never wanted to become a teacher, not either a university teacher. Mm-hmm. And I went into industry as an engineer, actually, production engineer, to the IT&T company, and was triggered into teaching and into university and into science by the University of Illinois in Urbana, where the department had called me and the president kind of invited me also. And from there on...
Who were those people?
Professor Demaris was the department head at the University of Illinois, of the Department of Business Administration. The name of the president I can't remember. And from there on, I always merged science and applications until today, actually. So that was the reason that, for instance, at my chair of operational research, where all the research was done, we were also application oriented. But typically, as in Fuzzy Sets, we did applications, empirical search and mathematical search in parallel, because to my mind they belong together. And all the application that we had, based, of course, on research which we had done before.
And you were the first chair of operations research at Aachen, but that's grown to 6 now?
To 5 chairs for operation research, yes.
So.
Yeah. And you mentioned, you asked how I was come or pushed into computational intelligence. And that was a very clear case. That was Lotfi Zadeh, the founder of fuzzy set theory. The article of him and Richard Bellman I read in 1972. That was the article in Management Science, and that was very exciting to me and started actually to influence all the next decades of my research and application.
And you called him at first, and then you visited him for a few days, I think it was, right?
No, for 2 weeks, right away.
2 weeks. Good.
After 3 weeks, after I had read the article, I was already in Berkeley discussing with Lotfi Zadeh.
Good, wow.
And he was very interested, particularly in the area of operation research, from which I came, because operation research was one of the main areas which was pushing more or less formal decision-making procedures, algorithms and so on. And of course, between his human-related theory of fuzzy sets and the mathematically oriented decision-making, operation research was a very strong relationship, and that was of particular interest. And he has been very often in Aachen in the meantime. And of course, I always am in Berkeley when I'm in the United States.
Good. So, if for the young researchers watching this, if you get inspired by somebody's research, try to visit them. It may result in a lifelong collaboration, or at least a lifelong friendship. So,
yeah, you are still very much invited and welcome in Aachen.
Vielen Dank.
And you can either come to any of the companies, Inform, MIT, or you can come to the university, or you can come to my home, or I will show you around. In Aachen, which was the European capital in 800, where Charles the Great resided in Aachen.
Let's do all of the above.
Okay. Thank you very much.
Good. And so let's see. We covered some of these 1, 2, 3. We've covered those. So we have a question we'd like to ask our Pioneer Award winners. And so I believe you won the Pioneer Award for your research that you mentioned and so maybe recap what you consider to be the contributions that led to the Pioneer Award, and what the challenges that you encountered in trying to take on this pioneering research.
Yes. I mean, I was, as I already mentioned, more or less invited or drawn or pulled into that area by the article by Lotfi Zadeh, and then afterwards by the type of research we did, which I think is extremely important also for applications and for other types of science. I had the advantage that operations research probably was the first discipline which in the 30s started working interdisciplinary. So when I started my chair in Aachen, I insisted that at the chair there were always at least 7 disciplines participating, doing research together. And I think that is one thing which is still missing. I mean, so far different disciplines move more and more to interdisciplinary work, but there are some disciplines, for instance mathematics, which hardly ever consider working together with another discipline. And that has also led to the fact that the Journal for Fuzzy Sets and Systems, which until last century, at the end of last century, was probably half application, half research, has become a very mathematical journal without any applications anymore. And I think in this situation we are missing quite a lot of application potential of computational intelligence. Now, computational intelligence already has three areas which certainly work together, but they are not really different in their characteristic and their focus. They are similar. While if you consider, let's say, mathematics, you have optimization algorithms, and psychology, where you study the human decision making, they are much more apart in their focus, but it's much more important that they get together if they really want to achieve results which consider as well psychological, human-related results as computer and mathematical results. And that is, I think, also one of the big challenges and potentials which I still assume for computational intelligence, where actually I have to confess that in the meantime fuzzy set theory is delivering much less to this area than the other parts of computational intelligence. Too bad.
So the area of interdisciplinary research.
Yes,
Yeah.
yes. And application orientation. Because actually they are all knowledge induced, at least neural nets. They are very asked for, of course, in so-called analytics, data mining, and these type of things. And the area of fuzzy clustering, for instance, fuzzy analytics, is a very powerful thing, but it is hardly ever used nowadays. And I think that one of the reasons is that students are taught and educated in digital thinking. And they find it very difficult to recognize the power of fuzzy set theory. And that's probably why fuzzy set theory has become a mathematical theory, while neural nets and genetic algorithms, they are still being applied, and they are accepted by everybody.
You mentioned when we were talking earlier also that that in the development of your research group, you found that it was about 10 times more expensive to do empirical research compared to the mathematical research. And so I imagine that if one is focused on federal funding, that is part of the reason for this tilt, and maybe one of the reasons that you were able to overcome that was that you had started these companies, and so that you could maintain that diversity where it might have been harder for somebody else to do the same thing.
Now, I think most of the research worldwide is still done by either state foundation or similar institutions. So our simultaneous research, empirical and formally in mathematics and psychology, was all founded by the state of Germany, as the German National Science Foundation. They founded it until the 80s, and I don't know the reason. Maybe that I have been convincing enough, or because the results that we achieved were internationally recognized. But one can find very clearly the development in the 80s that empirical research was diminished, was going down and down and down, and we only compared the efficiency, the publication efficiency, while we were doing research, mathematical research and empirical research in the same area, namely fuzzy decision making. And there it showed that for empirical research, or for one publication in empirical research, you have to work about 10 times as much as for a publication in mathematics.
I think one reason for that is that in mathematics you can decide what your assumptions will be and then prove what you need to prove. In empirical research, you don't get to decide what your assumptions are. The application hands you the constraints and you have to go with whatever it gives you.
Yeah, that is certainly correct. Most of the people in mathematics, even in operational research, or particularly in mathematical journals, also fuzzy sets and systems, they make assumptions, they develop a formal model, and then they solve the model, and then they publish it. Mm-hmm. But they never prove that their assumptions are relevant or correct. Mm-hmm. And that is exactly the difference between empirical research, where you check the validity of assumptions before you start building a theory. That's exactly the difference. Yes.
So that's why it costs 10 times more. But then, if you have any doubt of whether it's worth costing 10 times more, reconsider that company that was so successful, and remains so today. So we've covered far from everything, but we've covered a lot of ground of contributions. What contribution gives you the greatest satisfaction?
Well, I guess part of my life was always to improve systems or procedures or conditions which were not considered optimal by me. Mm-hmm. So it did not really matter what it was. So coming back from the United States, when I started there, it was first the condition of operational research in Germany, which I didn't like or considered suboptimal. Then it was the fuzzy area. Then it was the application or applicability of operational research and fuzzy systems, which made me start the tools, fuzzy tech and data engine. And so it is still the same whenever something occurs to me which seems to call for improvement, then I do it.
Good. I love to tell my students dissatisfaction is your friend, and you're living proof that if you're dissatisfied about something, it's an opportunity to do something about it. Yeah. So, good. So we talked a little bit about the coining of the term computational intelligence in 94 by happenstance a couple of years earlier, but as far as our society is concerned, in 94. So what do you have to say both about your impact in the society, but also the society's impact on you, the Computational Intelligence Society and its precursors like the Neural Networks Council, which brought fuzzy systems in, and so that's the reason for the term Computational Intelligence Society. What do you think is the impact that has had on you, and the other way around, your impact on that organization?
Okay, now the impact on me has been the influence and the working facilities actually of the last decades, where I was in addition to operations research, mainly active in the area of what we call now computational intelligence. First fuzzy sets, but then also the other areas. I think I have tried at least to create or generate areas of activities for these areas. And what has helped very much, and which is probably not recognized enough, is the fact that the names operations research and fuzzy set theory are very bad. Because I will tell you a story just in a second, why the name computational intelligence is extremely attractive. Also for it sounds modern, it sounds everything that you want of a new method. While operation research, if you want to apply it, always has the research in the background, and practitioners don't like research. So
they want to know what's going to solve the problem. Yeah.
And fuzzy sets exactly the same. Let me tell you a little story. I have been consulting the Naval Research Institute in Aberdeen for a couple of years. And the friend who invited me to do that told me when I started there, now look, you will have to do with officers, Navy officers, and they don't really like to be fuzzy. So a fuzzy decision maker is not really what you want to be as a military man. So be careful, or introduce it well, or describe it well. So when I had the first lecture already in Aberdeen, I was talking about F-sets. F-sets for programming and so. So somebody from the audience asked me, okay, what does the F stand for? And I told them it stands for flexible. And so everybody was very excited. Flexible decision making, that was something that military wanted to do. And much later, I mentioned, that sometimes it's also, the F stands also for fuzzy, but that this is not relevant for us. We will stick it to the, and that shows exactly how important the name of a theory is for the attractiveness of that theory for application is, and sometimes also for scientists. So for computational intelligence, I think we are on the right track.
That's sometimes a necessary marketing tool. Bernie Widrow told me he did the same thing with the Adeline. He would call it adaptive linear element or adaptive linear neuron, depending upon who the audience was. You mentioned Navy. Earlier you told me about another affiliation with the Naval Postgraduate School.
In Monterey, yes. I lectured a couple of semesters there on operational research. Because one of my friends, an American colleague whom I introduced into university life while I was in Urbana, ended up at the Naval Postgraduate School in Monterey, and he lives in Monterey also. So he visited. I have a common book with him on production control, intelligence, and so they invited me, and I liked it there. And the audience was quite demanding but interesting.
Good.
Navy officers.
Yeah.
So I think that was a very good place to go to.
Yeah. So you said a little bit about what you think needs to happen, more of the combination of the mathematical theory and the application, particularly in fuzzy logic. Do you predict any new breakthroughs, any new confluence or convergence of these technologies, or any potential new entry?
I guess all the methods in CI wanted to improve things. But I think you can divide them into two parts. One is the algorithmic part, which is particularly valuable in data mining, analytics, and so on. And the other is the so-called knowledge-based part, like expert systems and that type of thing. Now, for the algorithmic part, I think it's enough if you have mathematics, but the area which you research in analytics, for instance, sometimes is not too well suited. For instance, in our applications in banking in MIT, we found that clustering, to cluster the customers of a bank, does not at all lead to sensible results. There you need fuzzy clustering methods, such that Jim Betzlick has invented and applied very often. Now for the knowledge-based systems, it's different, because knowledge-based systems want to use expert knowledge and their kind of deriving solutions from assumptions. And if you want to do that, then you have to find out how experts are thinking and what they are doing or what they mean if they say something. We actually have the same in companies. For instance, in my company, in Inform, it starts with a potential customer. He corresponds with our salesman verbally in living language. Then the salesman tells the project officer what the customer wants. That will still be maybe written, but verbally, linguistically. Then they give that to the developer. He develops, or maybe already the project engineer, develops a formal model of what has been told to him verbally. So here it depends already, is this translation from verbal into formal model adequate or not? And the same happens, of course, on the later stages, which happen if you come to the program. And that is the area of expert systems or knowledge-based systems. And I think there you need empirical research. I think it's much too easy what colleagues do. For instance, in fuzzy sets and systems, they make the assumptions of how a fuzzy set looks like, what the operator is, and so on and so on, and then they develop their theory. Okay, fine, they can do that. But this theory is, to my mind, not useful if you really want the theory to solve real problems. And in this area, I think much too little has been done. Maybe because it's too expensive, maybe because people are no longer interested, maybe because it's easier just to take an algorithm and apply it than to find out what people really do in knowledge-based systems. In Inform, in the company, we combine things. As long as it is justifiable, we use a research report and find out what our customer really thinks or wants. If that becomes too expensive, we use a more heuristic approach. But that would be one area which would be very important, or is very important, which I think is neglected so far, the interdisciplinary research between human-related disciplines and mathematics or IT-related disciplines. That is very important.
Well, do you have any final comments or advice?
I would say for computational intelligence and friendly societies. They do a good job. Go on. Like in the past, the only thing which is, to my mind, somewhat neglected is the effort to make their approaches and the advantages of their approaches known and attractive to people in the practice. Now that seems to be one feature of all of the institutions, Euro, TIMS, ORSA. They try, but I think they do not try enough, and they don't try the correct way. They always assume that practitioners who have their practical problems read journals or newspapers or so on operation research or quasi-sets. They certainly don't. They might read something on computational intelligence because the name is attractive. And intelligence, the name intelligent, is used more and more frequently in all types of marketing environments. But I think in this area one could do more. In operational research, the Euro organization, which I founded in 76, no, 74. Okay, we have in the meantime 26 interdisciplinary working groups, which meet a couple of times, between 1 and 5 times a year, and in which scientists and practitioners are together. And I think they are doing an extremely well job of more or less marketing the area of research or computational intelligence. We even have fuzzy sets of working groups in practice. And I think that if an area does not want to degenerate to a former theoretical area, such as fuzzy sets, for instance, if you do not want that, you have to keep attracted to practitioners and to media. And everything that can be done in this direction is certainly very, very helpful.
Good. How about advice to students?
It's very difficult nowadays to give general advice to students. I think they should, on one hand, choose their area which they are interested and focused by. On the other hand, it should not be excluded that random will lead them to the optimal position in their life. And in that respect, I can certainly mention my own life. You might remember I did not want to become a businessman, a teacher, and was a civil servant. I always wanted to become an engineer. Now, in the meantime, I am all three of them. I'm a university teacher. I'm a civil servant because they are employed as civil servants. I'm an engineer and I'm a businessman. And most of that was really due to, I would say, random, at least not planned by me.
Yeah. And of course, I think also that the very hard work is a huge factor in that. When you're working a 48-hour work week and you add another 6 hours per day times 6, that's a lot of hours of very hard work, but the results speak for themselves. So.
And you have to be insistent. If you want to reach something, you cannot, must not stop before you have reached it.
Right. Even when people tell you no, you should not take no for an answer.
If you're convinced, then do it.
Also, sehr spannend. Vielen Dank. The story is truly exciting, and
Okay.
die deutsche Leute hat viel darüber sehr stolz zu sein. Ich habe viele Lob für unser Professor Zimmerman sehr viel Erfolg in seiner Forschung, and so tremendous contributor to the field and to the society. Thank you very much for taking the time for this interview today.
It was a big pleasure to me. I'm still working. You see, I'm in the 80s, but I can't actually imagine that I would stop that type of work. And I think it's sometimes a mutual type of thing. The work keeps you running.
Yeah.
And you run the work as long as you can.
Yeah, you still have the twinkle in the eye and the pink cheeks and the smile in the face. I think that the work is very good for you.
Okay.
Okay.
Thank you very much.
Vielen Dank.